Alright, so let's say you're confused on how to do confidence intervals and you want to get a little better at them. So today we're going to do one pulled straight from the AP Statistics 2022 free response questions on the AP exam. And so this problem states that a survey constructed by a national research center asked a random sample of 920 teenagers in the United States how often they use a video streaming service. From the sample, 59% answered that they use a streaming service every day. Construct and interpret a 95% confidence interval for the proportion of all teenagers in the United States who would respond that they use a video streaming service every day. So we're constructing confidence interval for proportions here, and the acronym we're going to want to use to help us with that is PANIC. Now, the first step of PANIC, as we'll see right here, is P, which is state the parameter in question. And we're going to do that by writing that we want to estimate the true proportion of all teenagers who use a streaming service every day. And this part's important. Let pi represent this proportion. Um, Essentially, that tells us that like this is what we're estimating, and therefore our confidence interval is based around this. So there's our p. Now we can't construct a confidence interval without having some conditions met, and that's going to be the next part of panic. That's the A, which stands for assumptions and conditions. Now, there are three of these that we need to construct a confidence interval. The first of which is a simple random sample, which is given in the problem. It's a random sample of 920 teenagers, so that's given. And the next one is the 10% condition. Now, the 10% condition allows us to proceed with a reliable standard error calculation, which is going to come later down the line. And we need to prove that uh, the sample size is less than or equal to 1/10 of the population size n. And the problem tells us that n, our sample size is equal to 920, so we're going to write that right there. And it doesn't tell us the population size because obviously the population size is unknowable in most cases. So we have to say that it's safe to assume that there are more than 9,200 teenagers in the world. And we follow it up by saying 920 is less than or equal to 1/10 of the population size n. Big fat check mark. And last condition that we need is the large counts condition. The large counts condition allows us to assume an approximately normal sampling distribution as long as the conditions are met where n times p hat is greater than or equal to 10 and n times 1 minus p hat is greater than or equal to 10. And so, like we stated earlier, our sample size n is equal to 920 and our proportion p hat is equal to 0.59 or 59% is what it said in the problem. Same thing. Uh, write our sample size there. And so we're going to write that 920 times 0.59 is equal to, just punch that into the calculator right there. You should come up with 543, which is obviously greater than or equal to 10. And you're going to do that for the next one, which is 920 times 0.41. That's 378. That's also greater than or equal to 10. Big fat check mark. That's large counts conditions met. And we're going to go on to the next step of panic, which is name the test. This is the shortest step, but it's one of the most important. You have to write that all conditions are met. Thanks for getting in my way, Hair. And we can proceed with a one prop z int. Now a one prop z int is the test that we're going to use, and we have to write that right there. And now we're on the I of panic, which is actually constructing the interval. And so I started off with writing the formula. Writing the formula is just good practice, lets the judges know that where you are in the process. And the formula for confidence interval for proportions is p hat plus minus z critical times standard error of the p hat. And I wrote the standard error formula under it. That's also on the formula sheet, so you just copy it from there. Square root of p hat times 1 minus p hat over n. And so we write down p hat and n one more time. P hat is equal to 0.59, n is equal to 920, excuse me. And write down your confidence level, which was given the problem as 95%, which the z critical for that is 1.96. Uh, and we can know that because 1.96 for 95% confidence rate is very common when constructing confidence intervals, so it's just good practice to memorize it. But if you need to, you can also use the inverse norm function on the calculator with the center tail function, using your mean and standard deviation that you would use in a z-score distribution, and find that 1.96 is the value that it spits out. So we're going to actually calculate our standard error here, uh, which is just as simple as plugging in our values. And I already had done this in the calculator beforehand. So the value that we're going to get here is 0.016. As you can see right there, yeah, 0.016 is our standard error, which we're going to write on the paper right there. And so now we have all the elements that we need to construct a confidence interval. So I'm going to write confidence interval for p hat is equal to 0.59 plus minus 1.96 times 0.016. And the interval we're going to get from this is 0.559 to 0.621. That's 0.621. And that's our interval. That is our calculations done. That's the math portion of Panic. Um, Combined with A, those are the math portions of the problem. And the last step is concluding, which is just interpreting the interval in context. And all we have to do for that is state our confidence level, say that we are this percent confident that the true proportion pi of all teenagers who use a streaming service every day is captured by the interval from 0.559 to 0.621. And you can play with the wording any way you want, as long as you have those elements in your answer, saying that 95% confidence, or whatever confidence level you might have in the problem that you're going to get, and say that you're confident that the true proportion pi lies in this interval, and then write your actual interval. All right, that's it. Thanks for watching, and I will see you in another practice problem. Take care.